So f of x is equal to x square. For x less than or equal to 1, it's equal to x. For x greater than or equal to 1. So for both these portions, it is continuous. Now we need to check at x equal to 1. So left hand limit. So left hand limit is limit x tends to 1 minus f of x. So x tends to 1 minus means values lesser than 1. So values lesser than 1 means this x is less than 1, so it will be x square. So f of x is x square, so this is limit x tends to 1 minus x square, which is equal to 1 square, which is equal to 1. Right hand limit x tends to 1 plus f of x, which is equal to limit x tends to 1 plus for 1 plus, for x greater than 1, it is equal to x. So it is 1. So left hand limit is equal to right hand limit. Function value at
So we
1.
can determine that this function is continuous, no sir?
Yes. No, third point is f of 1 equal to 1. It is defined by x square. 1 square, which is 1. So left hand limit is equal to right hand limit is equal to function value at 1. Therefore, function is continuous on R. Okay. Very simple question. Now, next question. F of x is defined by sine 2x upon x if x is not equal to 0. It is equal to 1 if x equal to 0. Is f continuous at x equal to 0? This is question 1. Check continuity of f of x at x equal to 2, where f of x is defined by half x square minus 4 for x lying between 0 and 2. It's equal to 0 for x equal to 2, and 2 minus 8x to the power minus 3 if x is greater than 2. Okay, so these two problems I'm giving. So attempt these two. I'll just join you back in a few minutes. Yeah. So now we are solving this question. F of x equal to sine 2x upon x if x is not equal to 0, and it's equal to 1 if x equal to 0. So is f continuous at x equal to 0? So at x equal to 0, the function is taking the value 1. So function value at 0 is 1. Next, now let us consider the left hand limit at 1. At 0. Limit x tends to 0 minus f of x. First we'll write. Now f of x, when x is slightly less than 0, is sine 2x upon x. Now sin x by x is a standard limit, and it is exists. Left hand limit is equal to right hand limit. So sin ax by x is a. Okay. Look at the right hand limit. This is limit x tends to 0 plus f of x, which is equal to limit x tends to 0 plus sine 2x upon x. Now, for only at x equal to 0, it is 1. For all other values, it is sine 2x upon x. So as x tends to 0, sine 2x upon x is equal to 2. So we get left hand limit is equal to the right hand limit, but it is not equal to the function value at 0. Therefore, f of x has what kind of discontinuity? F of x has a removable discontinuity. It has a removable discontinuity at x equal to 0. So left hand limit and right hand limit are equal to 2, but the function value is equal to 1. So limit exists, but is not equal to the function value. So it has a removable discontinuity. Now let's look at the next question. Okay.
Sir, in the next case, we are going to take the last one, right, sir? 2 minus 8x to the power minus 3. Or else should we take the first case?
No, you have to see both, na? See there. Continuity, we have to study the continuity at x equal to 2. So first thing, function value at 2. At x
Is
equal to
0.
2, function value is 0. Okay.
Yes, sir.
Next. Left hand limit. Left hand limit at 0 is limit x tends to 0, 2 minus. We are talking about 2 at 2. So x tends to 2 minus f of x. So when x is slightly less than 2, x is approaching 2 from the left. No, the first case, this one. X is slightly less than 2. So f of x is half x square minus 4. So applying the limit, you get half into 2 square minus 4, which is 0. Okay, now let us consider this one. Right hand limit. Limit x tends to 2 plus f of x. So when x is greater than 2, slightly greater than 2, x is tending to 2 from the values greater than 2. So what will be the function? Function will be
2 minus 8x
2,
to the power minus 3.
right.
So then how we will substitute?
When you substitute, you'll get 2 into 8 into 2 to the power minus 3, which is, this is 2 cube. All right, 2 to the power minus 3 is 1 upon 8, isn't it? And this is 8. So this is 2 minus 8 into 1 upon 8, which is 1. So 2 minus 1 is 1. So
Left
what
hand
you,
limit is not equal to right hand limit.
yes, left hand limit is not equal to right hand limit. Which kind of discontinuity is this?
Non-removable discontinuity, sir.
Yes, good. So f of x has a non-removable discontinuity.
Sir, f of 2 is equal to left hand limit, not equal to right hand limit, no, sir.
Right. At x equal to 2. So it has a non-removable discontinuity. So it is also called as jump discontinuity. It's also called as jump discontinuity.
Sir, but in the previous case, we have considered the sin 2x by x only for left hand limit and right hand limit, sir.
Why?
Because we did not have another function to consider, right?
Yes. These are
Okay.
called as piecewise defined functions. Piecewise
Sir,
functions.
piecewise defined functions.
Yes. That means in different intervals, the function is defined by a different expression. Okay. So this is f of x is for x not equal to 0, it is sine 2x by x. For other, it is 1. For x equal to 0, it is 1. So these are called as piecewise functions. All right, very.
Or in case if the third question has the third case as 2 minus 9x to the power of minus 3, then what would be the answer or the function, sir?
2 minus 9 by 8. So you will get a fractional value.
Okay.
Okay.
Fractional value are also considered
So
in this
if
limits.
function value, no, it can be anything. Now, if this was 1 minus 8x to the power minus 3, 1 minus 8x to the power minus 3, then you will get this answer as 0. Then the function would have been continuous throughout. Okay. Now let us consider another function. Uh, f of x is defined as x square minus 9 upon x square minus 2x minus 3. For x lying between 0 and 5, but x not equal to 3. And it is equal to 1.5 for x is equal to 3. Now check the continuity of the function. At x equal to 3. Check the continuity of the function at x equal to 3. So function value, first thing, function value at 3 is 1.5. Now other than 3, see, f of x for x not equal to 3, f of x is x square minus 9 by x square minus 2x minus 3, which is x minus 3 into x plus 3, the numerator. The denominator be x minus 3 into x plus 1. Minus 3 minus 3x plus x will give you minus 2x, and then product you can do. So you get x minus 3 into x plus 1. You can see this x square minus 3x plus x minus 2x minus 3. So you
X
get,
minus 2 will be cancelled.
right. So this will be your function.
Sir, is
So
this continuous at 3?
let us see. We
We
have
need to
not yet.
substitute the value, no, sir?
Let us see. Let us see. So left hand limit x tends to 3 minus f of x is equal to limit x tends to 3 minus x plus 3 by x plus 1. So you get, it is 3 minus, means of course it is not 0 by 0 form, so direct substitution. X is approaching 3 from the left. All right, it is not. So the value of x is tending to 3. 3 plus 3, 3 plus 1. So you get 6 upon 4, which is 3 upon 2, which is 1.5. Look at right hand limit. Limit x tends to 3 plus f of x is equal to limit x tends to 3 plus, you get x plus 3 by x plus 1. You get the same thing, 3 plus 3 upon 3 plus 1. It is 6 upon 4, which is 3 upon 2 equal to 1.5.
Is continuous at x tends to 3, no, sir?
Not x tends to 3, at x equal to 3.
X equal to 3.
So you get left hand limit is equal to right hand limit is equal to function value at 3, which is equal to 1.5. Therefore, function is continuous at x equal to 3. Continuous at x equal to 3. Next, we'll do one more. Fifth problem. Now, f of x is given by four minus x square if x less than or equal to 0. It is x minus 5 if x lies between 0 and 1, and 4x square minus 9 if x lies between 1 and 2. and it is 3x plus 4 if x is greater than or equal to 2. So discuss the continuity. Continuity of f of x. So this is a question. Now all these expressions, either they are linear or quadratic, they are all continuous. All algebraic functions, they are continuous. There's no throughout. Only when there is a transition, that is when you need to check. So at 0 we need to check, then at 1 we need to check, then at 2 we need to check, because across 0 the function's definition is changing, across 1 the function definition is changing, and across 2 the function definition is changing. So we need to check at 3 points in this case. So to check continuity at x equal to 0, comma, x equal to 1 and x equal to 2. So at x equal to 0. So function value at 0, when you substitute 0, this equal to sign for 0 is for this expression. That means function will be defined by 4 minus x square. So 4 minus 0 square, that is 4. Now let us check the left hand limit. Left hand limit function will be defined by this left hand limit, limit x tends to 0 minus f of x, which is limit x tends to 0 minus 4 minus x square, because when x is less than 0, function is defined by 4 minus x square. So you get 4 minus 0 square, which is 4. Now when x tends to 0 plus, okay. So limit x tends to 0 plus, function will now be defined by, when x is slightly greater than 0, the function is defined by the second expression, x minus 5. So now x tends to 0, minus 5 is equal to minus 5. So you get function value is equal to the left hand limit, but it is not equal to the right hand limit. So there's a jump discontinuity. Okay, so f of x is or has a non-removable discontinuity f of x has a non-removable discontinuity at x equal to 0. Now let us look at x equal to 1. at x equal to 1. At x equal to 1, first function value at 1.
X minus 5.
So x minus 5. Function is defined by x minus 5. So you'll get 1 minus 5, which is equal to minus 4. Now limit, left hand limit, x tends to 1 minus f of x. So when x is less than 1, function is defined by x minus 5. So the value tends to 1 minus 5 equal to minus 4. Function value equal to minus 4. Left hand limit tends to minus 4. Now let us look at the right hand limit. Limit x tends to 1 plus f of x.
Then it tends to 4x square minus 9.
So 1 plus, it is 4x square minus 9. Okay, so this is 4 into 1 square minus 9, which is minus 5. 4 minus 9 equal to minus 5. So you get again left hand limit is equal to the function value but not equal to right hand limit. So again you have a non-removable discontinuity. At x equal to 1. So are you understanding how we are applying the problem? Now you tell me the steps for x equal to 2. Now at x equal to 2. First step, let's check the function value at 2. Function is defined by which expression? Yes? Which expression?
What, sir?
For x equal to 2, what is the functional expression?
3x plus 4.
Very good. Very good. So 3 into 2, 6 plus 4, 10. 3x plus 4. This is the functional expression. Now, because x is equal to 2 is given. Now left hand limit. Limit x tends to 2 minus f of x. Limit x tends to 2 minus f of x. Limit x tends to 2 minus. What is value of f of x?
3x plus 4 only, sir.
No.
4x square minus
9, because x is less than 2. X is less than 2 because x is tending to 2 minus. That means we are approaching from values lesser than 2. So function will be defined by 4x square minus 9. So we get 4 into 2 square minus 9. So 4 into 4, 16 minus 9 is 7. Let's look at the right hand limit. Limit x tends to.
Sir, this function would be 3x plus 4, which is 10. So
Yes.
our requirement here is at x equals to 2, f of 2 will be equal to right hand limit but not equal to left hand limit, and this is a non-removable discontinuity at x equals to 2.
Good. Good. So here, left hand limit is not equal to right hand limit, but right hand limit is equal to the function value. So f of x has a non-removable discontinuity at x equal to 2. So at all three places, we had to check for x equal to 0, x equal to 1, and x equal to 2. At all these three places, we get a function having non-removable or jump discontinuity at x equal to 2. Now let's do one more, the last one probably for today. F of x is cos ax minus cos bx upon x square. If x is not equal to 0 and it is half b square minus a square if x is equal to 0. So is f of x continuous at x equal to 0? How do we do this?
First, we need to write it f is equals to 0, then f of 0 equals to 1 by 2 into b square minus a square.
Okay.
Then next, we need to substitute the value in cos ax minus cos bx by x square, wherein we have to find the left hand limit and the right hand. No. Need to find the left hand limit and right hand limit for 1 by 2 b square minus a square.
How will
If
you
it
find
is
that's a constant?
Oh, then we have to find it for the cos ax minus cos bx only, no, sir?
As x tends to 0 minus, for anything other than 0, function is defined like this.
So then what would be the value of this, sir?
You tell me. How will you find?
Cos ax minus cos bx. Sir, this is cos a minus cos b formula.
What is cos a
Minus
minus
2
cos?
sin a minus 2 sin a plus b by 2 into sin a minus b by 2.
Very good. Very good.
So,
Very good. You got it.
yeah.
So this is minus 2 sine ax minus bx upon 2 or plus and sine ax minus bx upon 2 by x square. So limit x tends to 0 minus 2 sine of a plus b by 2 times x sine of a minus b by 2 times x upon x square. I will write this as. Now this
minus 2 is the minus 2 is the answer for left hand limit.
no
Uh,
no think minus 2 into this is sine ax by x as x tends to 0 is
2x.
a.
Okay.
Sine ax by x, it cannot be x, x is tending to 0. Sine ax upon x is a. So similarly, this sine ax upon x as x tends to 0 is a. So 2 cancels. You get half a square minus b square with a minus sign. You get b square minus a square. Okay. Got it? Similarly, right hand limit will be exactly the same. Okay. You will exactly get half b square minus a square, same steps. So you get left hand limit is equal to right hand limit is equal to the function value at 0, which is half b square minus a square. Therefore, the function is continuous. Now what continuous at x equal to 0? Now what if you don't remember cos c minus cos d? Actually, we must remember. These are basic formulae, but what if we don't remember cos c minus cos d? So limit x tends to 0, either plus or minus cos ax minus cos bx upon x square. How can you do this? If function value is sure, limit value, how can you find? We can write this again. We have to use a trigonometric identity. Cos 2a is 1 minus 2 sine square a. So use this. Okay. So you get 1 minus 2 sine square ax upon 2 minus 1 minus 2 sine square bx upon 2 upon x square. All right. So you get limit x tends to 0, 1 and minus 1 cancel. Then you are left with minus 2 sine ax upon 2 by x. All right, I'll write one more line. Minus 2 sine square ax plus 2 sine square, bx upon 2 by x square. So this is limit x tends to 0. Divide, you get minus 2 sine ax upon 2 upon x, the whole square, plus 2 sine bx by 2 upon x, the whole square. So we get minus 2 into sine ax by x is a. So a by 2 the whole square plus 2 to b by 2 the whole square. So you get b square by 2 minus a square by 2. So limit, so x tends to 0, f of x is equal to f of 0. Therefore, f is continuous at x equal to 0. Okay, did you get this? So there are two ways to do it. I'm sharing this file. You please go through it. Apparently, this is not there in your intermediate syllabus. However, it is extremely important for IIT JEE, whatever basics I've taught. These are very preliminary problems from your textbook only. However, for IIT JEE, they are much more tougher problems. I'm just going to share this to you. So next class, that is on Thursday, we will do differentiability. Very, very important class. Very important class. Don't miss, because you will learn the fundamentals of differentiability.
Differentiation, sir.
Differentiability.
It's different from differentiation.
Yes, it is. How do you, whether a function can be differentiated or not? Okay, at a point.
Yes, sir. Yes, sir. Got it.
All right. All right.
Thank you, sir.
Thank you.